This section introduces about the concept of yield stress and proof stress. The yield stress and tensile stress of various materials are shown in the table. You can see that the tensile strength of hard steel is higher than that of mild steel. Mild steel is easier to be elongated, literally described as mild, which sounds like soft. The feature of mild steels is that they can be more elongated at lower stress values. Steel materials with higher carbon content needs higher stresses to be deformed. Hard steels cannot be stretched as mild steels. The stress required to deform the hard steel is higher. In other words, the tensile strength of hard steel is higher. By the way, the yield point cannot be clearly observed in the stress-strain diagram of hard steels. Not being able to observe them clearly means that the yield point cannot be defined. We are arguing about this issue in more detail later, including how to define the yield point of these materials. Anyway, we noticed that we define a parameter called proof stress. Normally, we treat the proof stress as yield stress of materials that do not have clear yield stress. You should note that the value of the proof stress are shown as yield stress in the previous table. For materials that do not show a yield point, such as hard steel, the proof stress is generally expressed as a value of yield strength. Let me stress again that materials may be categorized into two types. One is materials that has clear yield point. The other is materials that do not have clear yield point. Mild steel is the typical material that has the yield point. Then, how the materials that do not have a yield point, such as aluminum alloys and hard steels with a carbon content greater than 0.3%. When stretching such materials, the material exceeds the linear elastic region after a while. As explained earlier, when plastic deformation begins after exceeding the elastic limit, the relationship between stress and strain loses linearity and starts to draw a gentle curve. This is what happens when the plastic strain increases.